Assalamu alaikum, dear students. Hope you are fine and enjoying good health. I am Ahmed Mumtaz Mustahsan with your course CSC 141 Introduction to Computer Programming. In the last lecture, we talked about basic fundamentals of computer sciences and some basic concepts of computer programming. Today, I would like to start in the lecture number 3. I would like to start with the problem solving and implementation. Dear students, there are a couple of more lectures and then you will have an hands-on exercises on this course. I can understand that you might be feeling impatient to really work on the computer and write your first program. But before writing your first program, it's important that you know some basic fundamentals that are very essential before writing your first program. So, problem solving and implementation. Programming can be divided into two phases. 1, problem solving, and 2, implementation phase. The problem solving has got 2 steps: define a problem and design its solution. Define a problem means you are required to clearly describe the problem. What is the problem? What you are required to do? So once you describe the problem, then it becomes easy to find out its solution and concentrate to different solutions and select the most suitable and the required one for solving the problem. Step 2, design its solution. Produced an ordered sequence of steps that describes the solution to the problem. So here you are required to describe the solution. First, what you have done? You have described the problem. Now you are describing the solution, and you are describing the solution in steps. The phase 2 of the problem solving and implementation is obviously implementation. This implementation has got 4 steps. Write a code, जिसको कहते हैं कि प्रोग्राम आपने लिखना है, compile, link, test and run, or test and debug. So here are some technical terminologies which I would like to explain. These 2 phases can also be split up into 6 steps. यानी कि problem solving phase can be in 2 parts, जो कि हम already discuss कर चुके हैं. Define the problem to be solved and design a solution. So you can see that this is the problem solving phase. Implementation phase, step number 3, write a program that implements the solution. Step number 4, compiling the program. Step number 5, link object files. What is that? I will explain you. Step number 6, test and debug the program. So basically we can say that developing a program requires 6 steps. Describe the problem, design the solution, write the code, compile the code, link the code, test and debug your program so that you are sure that your program should run with all eventualities, with all combinations that you have thought of in your coding. So step number 1, coming back to defining a problem. Again, we break this very first step and we say that break the definition of the problem down into manageable steps. When you define a problem, before designing the solution, you can just break up the problem into different steps. For example, input. For example, you can say that input, you want to read the data from the keyboard. Processing. Suppose the problem is that you want to read the temperature from the keyboard, and if the temperature is less than 32 degrees centigrade, you can say that it is below freezing, and if it is above that, you can say that it is above freezing. So we can define the input, we can define the processing, and we can define the output. Processing, in this particular case, it is simply testing the temperature, range of the temperature, or the level of the temperature more precisely. And the output, display the result on the screen. We said that the output device is the monitor, is the LCD, is the screen. So you want to display the result on the screen. There could be few more components which could be the users, or which could be the feasibility and implementation. We'll be starting with very simple programs, so we might not require to identify the users. But when you will be writing some complex programs, some big programs, then you will be required to define who are the users of your program. कौन लोग हैं जो आपके प्रोग्राम को यूज करेंगे, उनका लेवल ऑफ एक्सपर्टीज क्या है. Okay, then the feasibility. Feasibility में, you might remember in the last lecture we talked about what time it will require to develop the program, how much maintenance time will be required, how much complicated it would be to maintain the program. So while defining a problem, you may define it in detail, and the best recommendation is that write down whatever you define, whatever you describe, write down all the steps: input, processing, output, users, feasibility. You may not be defining feasibility and implementation in the beginning, but whenever you define something, you describe something related to the problem definition, I suggest you to write down whatever the description you may write. Step number 2, design the solution. Designing the solution means, आपको याद होगा, we said that set of instructions is called a program, but the set of instruction must be certain order, must be certain sequence, must have some logic. So a sequence of language independent steps which may be followed to solve a problem is called an algorithm. अब एल्गोरिदम और कंप्यूटर प्रोग्राम में डिफरेंस है. Computer programs are the set of instructions written in a language, computer language, understood by the computer. Whereas when we talk about the algorithms, these are the set of instructions in which you provide the solutions. It may not be, or usually it is not, the computer language in which you develop the algorithms. There are two ways in which you can develop the algorithm. One is called pseudocode, the other one is called flowchart. Preferably using control structure. The algorithm that will have the set of instructions might be in pseudocode, might be in the flowchart. Then this set of instructions form a structure, and then you have to define the flow of the structure, so that you may define the flow of your algorithm first. Flow may be defined through flowcharts. So I said that there are two ways through which you can describe, define, develop your algorithm is number one, either in pseudocode, number two, in flowcharts. Let's move further. If we want to develop an algorithm in pseudocode, so we should know what is a pseudocode. Once again, it is a method of designing a program. Now, you are free to use English language, you are free to use mathematical equations. So, as long as whatever you describe is something that can be communicated to some other person, then it is a pseudocode. Because there are no real rules for pseudocode, no real language for the pseudocode. Different organizations have developed their own standards. So you may write down the pseudocode in a very simple like English language. For example, you want to write down an algorithm that describe how you can reach to your college in the morning, or what should be the sequence of activities you need to perform in the morning. So you can write down in simple English language. You get up early in the morning. Okay, how you will get up early in the morning? You need to maybe required to set up an alarm. So you want to get up early in the morning at 5 a.m. So you will set up an alarm for 5 a.m. Step number one, set up an alarm of 5 a.m. on your wristwatch or on your table clock. Once the alarm bells, you ring the ringing tone of your alarm, get up from your bed. Step number two, go to bathroom to fresh up yourself, get ready for your college or your school. Next step, take your breakfast. You may put a check here. If you are getting late, skip your breakfast. If you are partially getting late, skip your cup of tea or your partial breakfast. Next, you have to commute from your home to your college or to your school. Now you need to check the transport. If the transport is available, use your transport. Otherwise, you can use your public transport. In this way, you can reach your school or your college. It's very simple. You can just describe it into the steps, and this is algorithm. This is a procedure, and this could be followed by any student who wish to reach at the school or college in time before the first lecture begins. So the pseudocode is a code which can conveniently understood and exchanged between computer professionals. Usually it can be communicated between non-computer professionals also, non-IT professionals also, but usually we say that you can exchange your algorithms with IT professionals. Once again, coming back to our previous example, where we said that I've described it here. Read in the temperature. If the temperature is less than 32, indicate below freezing on the screen. Else, if the temperature is above freezing, then indicate the same on the monitor screen. So how can we divide above problem into manageable parts? Input, read the temperature from keyboard. Processing, test the temperature below or above freezing. Output, display the result on screen. Let's develop the algorithm. Read the temperature. This is not a statement written in a programming language. This is the statement written in a pseudocode. It is up to you how you would prefer to write this pseudocode. Next, processing part. If temperature is less than 32, then print below freezing, else print above freezing, and if. So, an algorithm, very simple algorithm. It has got just one input, one testing statement, and one output statement. When I talk about control structures, flow structures, then I'll talk about the if structure also. But at this stage, our objective is to see an example of the algorithm. Next option we can have is the flowchart. It's a diagrammatic or graphic representation of steps for solving the given problem. You might find pictorial representation of steps. These are basically the graphical steps standardized and finalized by the American National Standard Institute. That's why we call it as standard symbols by ANSI, American National Standard Institute. What are these? These are just very few symbols that I will be using today in my sample flowcharts. There are few more. So whenever I will use those symbols, flowcharting symbols, I will explain and introduce those symbols to you. So building blocks of flowchart. You need to start a flowchart. Obviously, to start an algorithm, you need to start a flowchart with a symbol. There are three options used by different people. One is a circle, second one is an oval, third one is an rectangle, but it is slightly rounded from the four corners, and usually it is a smaller one. So you can use any of these three symbols to indicate the start of your flowchart. Then comes connector. It is again the same circle. We use the connector to connect the flow. What does it mean? Suppose you are coming from one sequence of symbols and then you want to transfer the control from that symbol to some other symbol. So what you will need? You will need an arrow, which is an indicate flow of control. It is an arrow. This arrow could be in any direction. Four directions: up, down, right, left. So I will come back again to the connectors after explaining these couple of more symbols. Processing step. This rectangle is usually depicts the processing steps. As I explained earlier, the previous rectangle you have a rounded shape, but this one is a sharp corners, and it is a rectangle representing the processing steps. Next is the parallelogram, which represents the input output. So the input output, you can represent the input output in your flowchart by using this parallelogram, which is like a rectangle, but it has the parallel sides. मुतवाज़ी लाइनें हैं आपस में. Next one is the decision box, very important. Diamond box, decision box. This is a square but used in a diagonal form. This decision box can have one input, it can have one output, second output, three output. So with one input you can have three outputs in this decision box. Usually with one input we use two possibilities, yes or no, but there are certain cases where we are required to use the three outlets, three corners of this decision box. So with this brief introduction of the symbols, let us take the example, same example which we have practiced few minutes back. So if the same problem, then obviously we'd like to have the same definition, same input, read the temperature from keyboard, processing, test the temperature, level of temperature, output, display the result on screen. Okay, this is your first flowchart. Start symbol. It is slightly, people have slightly modified it. Okay, मैंने आपको जो दिखाया था that was rectangle, but यहाँ पर इसकी दोनों sides जो हैं are circular. So you can use it. This is again slight modification in this symbol. Start your program, start your flowchart. Step number 1. Okay, this is arrow. From start the flow comes to the next symbol, which is an IO box. Read the temperature. So obviously it is an input of this algorithm, input of this flowchart. This algorithm is depicted through a flowchart. Previous algorithm was depicted through a pseudocode. Okay, next is our decision box. You can see this decision box, you are using three sides. One is in and two are out. Flow comes here. After reading the temperature from the keyboard, now you test the temperature. Simple. If the temperature is less than 32, no. इसका मतलब है temperature ज़्यादा है, so it is above freezing. Or if the temperature is less than 32 Fahrenheit, otherwise आपको पता है कि freezing temperature is below 0. But in this example, it is assumed that the temperature input has been taken in Fahrenheit. Once again, very good point. While describing the problem, means defining the problem, you may describe the characteristics of the input, which type of input unit you are going to key in. जैसा कि मैंने भी आपको बताया कि आप टेम्परेचर जो है वो सेंटीग्रेड के अंदर भी की इन कर सकते हैं और फ़ारेनहाइट में भी कर सकते हैं, लेकिन आपको पता होना चाहिए कि फ्रीजिंग पॉइंट जो है, अगर सेंटीग्रेड में टेम्परेचर की इन करेंगे तो फ्रीजिंग पॉइंट बिलो 0 होगा, और अगर फ़ारेनहाइट में टेम्परेचर की इन करेंगे तो फ्रीजिंग पॉइंट बिलो 32 डिग्री फ़ारेनहाइट होगा. So that could be a good example to describe the characteristics of the input also. Then you can see two more boxes. As per your convenience, आप देख रहे हैं कि यहाँ पे जो read temperature का box थोड़ा सा छोटा है, whereas print write और print का box पड़ा है, it's mean that it is basically the shape that determines the symbol. Shape of the symbol determines कि ये किस किस्म का box है, किस किस्म का symbol है, and what is the purpose of that particular symbol. So you are not required to have the same sized symbol used in the same flowchart. जैसी ज़रूरत है उसके मुताबिक आप उसके flowchart के symbol को छोटा भी कर सकते हैं और उसको बड़ा भी कर सकते हैं. Then out means end. So you read a temperature. If it is less than that, no, you come up here and you end from here. तो आपका flow of control is from the right side, and if the temperature is less than 32, then your flow of control is from the left side, but from any of these sides you end up here. You may have more than one exit in the flow chart, but it is usually considered a good practice to have one in and one out. Means एक start और एक end होना चाहिए. Mandatory नहीं है. इसी तरह कुछ languages के अंदर भी mandatory नहीं है कि आपकी language जो है प्रोग्राम एक जगह से enter होगा, start होगा और एक जगह पे end होगा. It may end at anywhere. लेकिन फ्लो चार्ट के केस में हम प्रेफर करते हैं कि we consider it as a good practice if we depict or prepare our flow chart that has one start and one end. Good. So I think you have a good understanding of the flow chart. Let's take few more examples. I'd like to use couple of more examples to repeat the pseudocode and the flowchart. Example number 2. Determine the sum of first 50 natural numbers. Natural numbers from 1 to n. So we want to know what is the sum of n natural number, and the n here we defined equal to 50. Let us define the problem first. Break into steps. ये कौन सा steps को हमने further steps में break कर रहे हैं? Define the problem. Defining the problem हमने उसको break up किया input, processing, output. Input is nil. We don't need input natural numbers to be keyed in from the keyboard. हम बड़ी आसानी से first 50 natural number जो है वो generate भी कर सकते हैं. हमें 1 से लेके 50 तक from 1 to 50 कीबोर्ड से इन करने की जरूरत नहीं होगी. यहाँ पर we'll see how. Processing. Sum the numbers from 1 to 50. We need to add 1 into 2, 2 into 3, 3 into 4, 4 into 5, and so on. Then 46 into 47, 47 and 48, and so on up to the level, up to the point where we add 1 to 50 numbers. And then we need to display the result. And result is, suppose, sum. पहले तो हम इसका बनाते हैं सूडो कोड. 1. Set n is equal to 1. Set sum is equal to 0. Algorithm की terms में and in the terms of computer programming, we call step number 1 as initialization step. We need to initialize the input. I need to define some more concept here, but initialization means to assign some initial values to what? I need to define a concept which is called variable. Remember, we talked about RAM, we talked about memory. When we want to access any memory location of the computer, we need the address of that particular memory location. It is really difficult to find out the address of any particular memory location. So what do we do for that? We define a variable. What is a variable? Variable is the name assigned to memory location. तो suppose आपकी memory location का address है 20,880, but when you defined a variable, say n, and this address is assigned to n, then you are not required to remember that particular number. Now you can access that number by using the name that you have given n. Similarly, we have defined another variable जिसको हमने नाम दिया sum. I'll come back to this in the maybe in the next lecture when I will discuss the data types. So coming back to the pseudocode, step number 1 में we have defined n is equal to 1, then we have initialized sum is equal to 0. Sum is the container that will contain the output. So हमने उस कंटेनर को empty कर दिया, initialize कर दिया 0 के साथ, so that it may not be having any previous data in it. Step number 2, repeat step 3 and 4 while n is less than equal to 50. Here we have defined के next 2 steps, which is step number 3 and step number 4, we need to repeat these 2 steps again and again. It has got certain name that I will explain you very shortly, but for the time being we'll say that this algorithm desire या require that the step number 3 and step number 4 should be repeated till the value of n reaches 50. यानी कि while n is less than 50, it should be repeated again and again and again. So what will happen? Step number 3 में we say sum is equal to sum plus n. So initially sum की value 0 और n की value 1, तो हमने 1 को sum में transfer कर दिया. Step number 4, n is equal to n plus 1. Now n is equal to n plus 1 मैथमेटिकली तो इनकरेक्ट हो सकता है, लेकिन कंप्यूटर की टर्म में इट इज नॉट एन इनकरेक्ट स्टेटमेंट. इसका मतलब ये है कि n के जो कंटेंट्स हैं उसमें 1 ऐड किया जाए और उसको n वाली लोकेशन पर स्टोर कर दिया जाए. सो n के प्रीवियस कंटेंट्स थे 1. व्हेन यू एडेड 1 to 1, now the value of n becomes 2, and then you go back up again because value of n is less than 50, so you add 2 to 1, it will be 3, then you increase the value of n, it will be 4, 5, 6 until it reaches 50. जब 50 के बाद हम इस स्टेप पे पहुंचेंगे तो n की वैल्यू होगी 50 plus 1, 51. और our algorithm says कि when the value of n crosses 50, then we should not repeat step number 3 and 4. So where to go? So we'll skip step number 3 and 4 this time and we'll go to step number 5, where we will print the sum. End. So we have developed our second algorithm. This algorithm we have developed in a pseudocode. Would you like to develop it in flowchart? Why not? Same algorithm, but this time we are using the flowchart symbols. Start the program. Now this is not input output, this is a square symbol where we say that sum is equal to 0 and n is equal to 1. Then there is a input flow to this decision box. Here you test n is less than 50. If it is less than or equal to 50, I think it should be yes. If n is less than 50, then it should be, we add 1 to n, add the sum, go back again. Okay. Then if n is not less than 50, rather n is greater than 50, then it will exit and it will print the sum. The sum which is updated here will be printed here. Okay, so we start, initialize. If n is greater than or equal to 50, no, then increment n, loop, and then if n has crossed 50, then yes, then exit, print the sum and end. So the same algorithm, it is written in pseudocode here and it is written in flowchart, depicted in flowchart. So we have developed two algorithms in both pseudocode and in flowchart. Let's take another example. Calculate the factorial of a number. You have to read a number from the keyboard, n from the keyboard, and you need to compute the factorial of that number. So need to define the problem. First of all, the input number is n. Processing. What is a factorial? I'm sure you have studied the factorial in your mathematics course. So how you calculate the factorial? Factorial of n is equal to n multiplied by n minus 1 factorial. Then what is the factorial of n minus 1? It is n minus 1 multiplied by n minus 2 factorial. So if we need to compute the factorial of 4, it is 4 multiplied by 3 factorial. Factorial of 3 is equal to 3 multiplied by factorial of 2. Factorial of 2 is equal to 2 multiplied by factorial of 1. Factorial of 1 is equal to 1 multiplied by factorial of 0. Since the factorial of 0 is equal to 1, so you calculate factorial of 4 equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. So what we have done here, we have simplified the problem. We have translated the factorial into a simple mathematical equation. Factorial of n, we have translated it into n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, so on until 3 multiplied by 2 multiplied by 1. This is one way of solving the problem. When we will reach some advanced stage, we will again pick up the same factorial problem, but that time we will solve it in using some advanced techniques. The techniques which are more closer to the one that you have studied, that is factorial of n is equal to n multiplied by factorial of n minus 1. But at this stage, just to explain you how can we simplify a problem, how can we simplify the processing, we can translate any problem using our knowledge, using the mathematical equations. We can simplify the processing. Once the processing is simplified, then it becomes easy to code and easy to develop its program. So here we say that input number, once again a variable n, then processing, we defined another variable which we call it as a factorial. We say that factorial is equal to that equation, this equation, and then we say that output factorial. Now determine the factorial of an input number. Just to keep the algorithm simple, we assume that the number is positive. Okay, so let us develop the algorithm pseudocode for computing the factorial of a number. Here I would like to caution you that when you will write down your program for computing the factorial, please do not use n to a very large value. Use it around or within 20, factorial of 20, or maybe less than that. I will explain it later on in the next lecture when I will explain the data types and their capacity and their limitations. This is just a caution. So let us develop the algorithm. First we will develop the algorithm in pseudocode and then in flowchart. Initialization step, set factorial is equal to 1. This time we have only initialized factorial, not n. Why? Yes, you are right. क्योंकि n को तो हमने कीबोर्ड से रीड करना है. So we are not required to initialize n here. Second, last time हमने sum को declare किया था, initialize किया था to 0. Here we are setting the initial value of factorial equal to 1. Why? अगर आप देखें हमारे solution के अंदर all the numbers are being multiplied together. अगर हम factorial की first value जो है वो 0 ले लेंगे and then multiplying the number with 0, your result will be 0. So you have to be very careful while initializing the initial values of a particular variable. Okay, read n from keyboard. IO statement, then test statement. If n is equal to 0, go to step 6. This is very useful. Go to. But in good programming practice, we will avoid this go to. And I will explain you why we should avoid this go to statement. But for developing the pseudocode, for developing the algorithm, this is perfectly alright using the go to statement, because it is very simple and easy word that communicate the meaning. यहाँ पे हम कहते हैं कि if n is equal to 0, go to step 6. What will happen? Suppose you have entered the value 0 and it will go to step 6 और factorial की value जो यहाँ print होगी that will be equal to 1. It is the correct answer. Why? Because factorial of 0 is equal to 1. But if it is not 0, it have some higher value, then we say factorial is equal to factorial multiplied by n. So you multiply it, you know the initial value of factorial was 1, and you have multiplied it now with n. Then next step, n is equal to n minus 1. In the last algorithm, we said that n is equal to n plus 1. So this is again a very important statement. जब हम कहते हैं n is equal to n plus 1, हम इसको कहते हैं increment. और जब कहते हैं n is equal to n minus 1, इसको कहते हैं decrement. So n is equal to n minus 1, reduce the value of n by 1 and go to step 3. Since you are keep on reducing the value of n, so 5 से 4 होगी, 4 से 3, 3 से 2, 2 से 1, 1 से 0. So whenever it will be 0, you will come out of this sequence of execution 4 and 5. यहाँ पे हमने वो while वाली statement use नहीं की है, बल्कि हमने यहाँ पर go to statement use की है. This is very important because this is another way of describing the algorithms. हम यहाँ पे while की statement भी use कर सकते थे, but that's the way you can develop your algorithm at your own convenience, at your own choices of the words and the statements. So that's why the algorithm is basically your copyrighted algorithm. So once this value is reduced to 0, then thanks to the statement number 3, that will transfer the control from statement number 3 to statement number 6, where you will print the result and end. So we have developed a pseudocode with some more variety and more instructions. Let us see how does it look like with a flowchart. Same problem definition वही रहेगी, designing solution same, but this time this algorithm is represented by using the flowcharting symbols. So you start the flowchart, read from the keyboard value of n, initialize. You can interchange these two also, because it doesn't harm, because the control will only follow once. सिर्फ एक दफा फ्लो यहाँ से गुजरेगा, लिहाजा इन दो की जो सीक्वेंस है वो आप कुछ भी रख सकते हैं. Then come this test. If n is equal to 0, you will exit from here and you will print the fact. Here factorial की जगह पर I am using the variable fact. So you can use a name, you can use any number of variables you like, or you can assign any name to any variable. तो यहाँ पर हमने factorial को fact का नाम दे दिया, short कर दिया. If n is equal to 0, no, then we say fact is equal to fact multiplied by n. ये आप देख रहे हैं steric. Usually we use this steric to represent multiplication. जैसे आपके कुछ calculators में भी use होता है, but mostly the calculator contains multiplication operator. But here we use this steric operator that represent multiplication. Then comes the decrement. After decrementing the value of n, this loop is repeated again and again till the value of n reaches 0. Then we exit and then print the value of fact and end. So again, this flowchart has a value start and end. So we have completed first phase of what? Problem solving phase, where we have completed define or describe the problem and design the solution. Before I start with the implementation phase and discuss write, compile, link, test, debug, I would like to discuss control structure. थोड़ा सा मैंने तस्करा किया था कुछ देर पहले. This is basically the flow, वो फ्लो जिसका कि मैंने जिक्र किया था एल्गोरिदम में भी, वो फ्लो जो कि आपको फ्लो चार्ट में भी नजर आ रहा है. This is basically the flow of your control. जैसे आपको याद होगा फ्लो चार्ट में राइट साइड से भी आप जा सकते हैं, लेफ्ट साइड से भी जा सकते हैं. If the decision box says yes, you can use the right path. If the decision box says no, then you can use the left path. So before I go to the second phase, I would like to define the control structure here. Just आपको एक brief सा introduction देने के लिए I would like to explain control structure. A control structure or logic structure is a structure that controls the logical sequence in which the instructions are executed. कौन सी set of instructions जो हैं वो आपने execute करनी है, किस path के through आप जा रहे हैं अपने algorithm के अंदर, अपने program के अंदर, कौन सा path follow कर रहे हैं. So there can be different controls. These controls are called sequence. Sequence वही है कि one after the other, first step, second step, third step, you follow all the instructions in a sequence. This is called sequence. Next is selection, decision box के through, in flowchart या if statement के through in a pseudocode. You can determine your path. If true, then do this. If not true, then do that. This is the selection. Next is iteration, repeating again and again. Remember, हमने कहा था कि repeat step 2 or 3 or 3 or 4 while such and such condition remains. So you repeat set of instruction number of times. This is called iteration or a loop. It was important to discuss it here, but I'll be discussing it in much more detail in the subsequent lectures. So coming back to our same developing a program, 6 steps of developing a program. We have already discussed first 2, problem solving phase. Now I would like to talk about the remaining 4 phases, which is called implementation phase. Okay. Implementation phase, 4 steps. Write a program. Source code. जो प्रोग्राम आप लिखते हैं उसको हम कहते हैं source code. Obviously it is in a particular language. हमारे केस में it will be C language, C++. Next, compile a program. It converts a source code to a object code. Source code which you and me, a human being, can understand. Object code that the computer can understand. Then link a program converts the object code to executable code. Although the object code is understood by the computer, but yet it has got some deficiencies. We need to resolve those deficiencies. I will explain you what are those and how can we resolve that. So we use link a program that converts object code to executable code. Next, test and debug. Rectify the errors in your program. So let us discuss these 4 steps. Write a code. This is step number 1 or phase 2. लेकिन अगर हम प्रोग्रामिंग के स्टेप्स की बात करें तो this becomes the step number 3. Create a source code. We need an editor. We used to have 2 types of editors. Historically, we used to have the line editors, where we perform the editing line by line. There was a very well-known editor, VI editor, which was provided by the Unix operating system. People take the pride that they know VI editor. But now, with the lot of development, this line editing has almost obsoleted. Now you prefer to use a screen editor, like your notepad, like WordPad, or like customized editor. What are these customized editor? Customized editor are more educated towards the language. They help you by identifying the errors while you are typing, while you are writing the code with the help of these customized editor. So we'll also be using a customized editor for our Visual C programming in this particular course. After writing the code, you are required to save the file. For that purpose, there is an default file extension. Depending upon the compiler we are using, there can be 2 types of default file extensions. For example, .c means myprogram.c, firstprogram.c, a.c. This indicates that the file contains a source code. Or a.cpp, first.cpp, myprog.cpp. That shows that the file contains a source code of C++. Next, compiling a program. For every language, you are required to have a compiler. आपको याद होगा, we talked about syntax and semantics. This is the responsibility of the compiler to check the syntax of the language. So if you are using a Fortran language, you must have a Fortran compiler. If you are using a C language, then you should have a C compiler. What it does? It converts your source code into code. Object code is basically a machine code. But you cannot execute this machine code because different sections of the codes are not mapped together. We call it as not linked together. Few minutes back I've just explained variables. So when you assign certain name to certain memory location, now this is the responsibility of the linker to link up those addresses, means address translation of those addresses, memory addresses, with the statements. Okay, do you remember in the last lecture I talked about fetch, decode, execute, store. What was fetch? To read the data from the memory into CPU. अब किस मेमोरी लोकेशन से डेटा आपने पिक करना है, फेच कहां से करना है, मेमोरी के किस सेल से डेटा उठाना है. It requires certain address. and that address is provided by the linker. तो हम कहते हैं linker provides the address translation. With the help of this address translation, the program is able to pick up the required data from the memory and fetch it to the CPU for the execution. So I hope you have understood the purpose of a linker. Next step is, okay, quickly repeat. So as I said, the compiler translates source code to object code, whereas the linker translates the object code to the executable code. So if you have a program named first.cpp, it was your source code, you have compiled that program, the compiler will output the result in first.obj. When you use the linker will pick up first.obj and it will produce first.exe. So that will be your executable. Now you can execute first.exe now by simply writing first.exe on command prompt, or maybe just even writing first on the command prompt. I'll explain you and I will demonstrate you how can you execute this. Test and debug the program. Rectify logical errors in the code. You develop an algorithm, it may contain some logical error. Because the syntax error, the compiler picks up all the syntax error and help you to clean out the program by rectifying all the syntax error. So before executing a program, you must rectify all the syntax errors. But compiler cannot determine the or rectify the logical errors. Logical errors जो आपके algorithm में है. So for that purpose, you can rectify these errors manually, or the computer can assist you with a tool called a debugger. Debugger provides you a lot of facilities. You can execute the code line by line, step by step, or maybe in one go. And after executing each line, the debugger facilitates you to view or to see the contents of registers, memory locations, CPU registers. So you can see what was the input, and after the execution of the instruction, what is the output. In this way, you can find out any logical error that might exist in your code. Not only the contents, but you can also determine the flow of the program. अभी मैंने बात की थी कंट्रोल स्ट्रक्चर की, जो डिटरमिन करता है कि कौन सा पाथ आपने फॉलो करना है. सपोज आप अज्यूम कर रहे हैं कि योर प्रोग्राम विल फॉलो पाथ ए, बट somehow due to some error the program might flow through path B. So this type of logical error can also be picked up with the help of debugger. Usually the debuggers are very powerful, and we use the debugger when we are writing very complex programs. So students, we have discussed in detail the 6 steps required for developing a program. Now, how can we execute a program? We can execute a program in 2 ways. One, using command prompt. For example, we used to have a command prompt in DOS. We used to have a command prompt in Unix. Even you can have a command prompt in Windows. And second option is we can use integrated development environment, IDE, integrated development environment. So we have these two options. I'll explain it in further detail. If you are using a command prompt, then for compiling a program, you must have all the source files with an extension of .c because I assume here that we are using C compiler. And the name of the compiler is GCC. It is available in Unix environment. Compiler in Unix environment is called GNU-C. GNU, GNU. GNU कहते हैं. GNU is not Unix. ये बहुत मजे का ऑब्जर्वेशन है. इंशाल्लाह टाइम मिला तो मैं आपको यकीनन इसे फर्दर एक्सप्लेन करूंगा किसी नेक्स्ट लेक्चर में. So here we use this GCC compiler on command prompt and we pick up all the source files. We use these headers files. ये header files जो हैं, these are basically the libraries that we combined with our source files, combine both of them together using a GCC compiler. Then the compiler produces object file with extension .o. Here we can use additional object files together. We can also add on libraries. Combine all these three as an input to the linker, and then the linker produce the executable which we can execute. We can execute directly on the command prompt, or we can take this executable to a debugger for debugging purpose. So this type of execution we perform if we are working in a command prompt environment. But if we are working in an integrated development environment called IDE, then we have got the source code editor as tool number 1. Then we have got the compiler or interpreter available within this IDE environment. Today I will just quickly go through it. The difference between compiler and interpreter is compiler translates complete code in one go, whereas interpreter translate the code line by line. I will again explain it in future, some more interesting differences between compiler and interpreter. Then we have got another tool which is called build automatic tool. This build automatic tool do everything in one command. Compile, link, execute. It can do it in just one click. Then we have got a debugger also, and it's a menu driven environment where we have got all these facilities. Here I would like to inform you that inshallah we'll be using Visual C++, which is the component of Visual Studio, and inshallah in the next lecture I will also explain you how can you set up a Visual C environment for your programming purposes. So before I complete this lecture, I would like to discuss typical C environment. We need editor, and that editor is required to create a source code, and that source code we save it in a file, means we save it on a disk. Then we need a compiler, but here in this slide you will see preprocessor. This is something that I will explain you in the next lecture. आज आपको सिर्फ इतना बताता हूं, program contains the instructions which are for the computers, whereas the preprocessor contains the instructions which are for the compiler. तो अगर आपने कंपाइलर को कोई इंस्ट्रक्शंस देनी है उसके लिए हम प्री प्रोसेसर्स यूज करते हैं. Using the compiler you can convert your source code into the object code, and that object file you can save it onto the disk. Using the linker you can convert the object code into the executable code and save it onto the disk. The future may you can use the executable code and you are not required to compile link again. Then you require a loader. Once again, this facility is available in IDE environment. Loader basically loads the program into the memory of the computer. Or once your program is in the memory of the computer, it is in the form of instructions. If it is in the form of instructions, then we know it very well that now we can fetch the instruction into CPU, we can execute the instruction, we can save the result back into the memory, and then from the memory we can take the result and print it onto the print screen. At this point, I would like to stop. If you have any difficulty, if you have any problem, any query, please visit the portal, course portal of CSC 141 Introduction to Computer Programming. Myself and my TA will be there to help you out to understand any complicated concept or anything that you want to understand. I'll be there inshallah with the next lecture shortly. Till then, Khuda Hafiz.